In our MOOC, we have a central case study which runs throughout all the weeks. It illustrates all the aspects of a typical biotechnology process, and we as teachers have chosen the production of 1,3-propanediol from biomass for that. The reason behind this choice is that 1,3-propanediol is already on the market as a bio-based product, and because its success can serve as a best practice. Therefore, I would like to introduce you to the product, propanediol. Propanediol, commonly abbreviated to PDO, is a clear, colorless and odorless liquid, which has a low toxicity and is biodegradable. In the picture you can see this clear liquid on the left, which is bio-PDO. The molecule has 3 carbon atoms and there are 2 hydroxyl groups on each side. You might wonder what the product is, which is in the right bottle of the picture. That's actually the polymer that you can make from propanediol, and we will come to this in a minute. The propanediol is produced by microorganisms using sugars from biomass. The propanediol is not always the final product. It's what we call a platform chemical, because it's an intermediate molecule applicable for many purposes. As such, propanediol can be used as a solvent or as antifreeze agent. But as building block, it can find application on a much larger scale in the pharmaceutical and plastics industries. That is why 1,3-propanediol can be denoted as a platform chemical. One of the most widespread applications of propanediol is in the polymer PTT, which stands for polytrimethylene terephthalate. The company DuPont sells this polymer under the name of Sorona, and Shell produces a similar polymer which is called Cortera. The polymer has very beneficial properties. The polymer beads on the right can be used to make fabrics, as a simple fiber or as construction material in the automotive industry. But if you consider sales numbers, carpets are an enormous important application of propanediol. In order to make the polymer, you need to combine propanediol with terephthalic acid, which has a benzene ring in the middle and 2 carboxyl groups on each side. This compound is currently not available from bio-based resources. Through a polycondensation reaction of propanediol with terephthalic acid, polytrimethylene terephthalate is produced. The beneficial properties of PTT are related to its 3D structure, which is curved rather than straight. PTT can therefore replace a number of applications where nowadays PET is used. PET stands for polyethylene terephthalate. In this case, ethylene glycol instead of propanediol is used as monomer and results after polymerization in a straight configuration. Because the PTT polymer has a different shape, it has more advantageous properties for polymerization. So there's really an added value to making propanediol as a building block for these polymers. At present, propanediol is made from propylene or ethylene. Both propylene and ethylene are products from the crude oil refineries, and by using catalysts in several steps, you can make propanediol from fossil resources. However, biotechnology enables us to make propanediol from a renewable feedstock. And in this scenario, you start from biomass, which provides the sugars, and then help with microorganisms, you can produce the propanediol. The advantage of using a renewable feedstock is a smaller environmental footprint and lower manufacturing costs. Also, the capital investments for these type of processes are typically low. All these advantages result in a lower price for propanediol and a higher availability of PTT for the market. Now looking into more detail to the PDO production case of this week. First, we have to start with a suitable source of sugars. In the case of second-generation biomass, this implies a pretreatment of the biomass source. The microorganisms will start converting the sugars in a process which is called fermentation. However, in the factory, still a lot of other things need to be done to obtain a pure product applicable for PTT production. The polymer needs to separate the propanediol from the fermentation broth and has to deal with the impurities. Finally, to get fiber-grade propanediol, it needs to be refined, which is usually carried out by distillation. What it eventually comes down to is putting it all together. So a biotechnological process is not just about fermentation with microorganisms, it's also about dealing with flows going in and out. There are numerous reasons why fossil-based PDO should be replaced by bio-PDO. To sum up, for the production of propanediol, according to a study carried out by Dupont and Tate and Lyle, it's economically more favorable than fossil-derived propanediol. It consumes 40% less energy. It reduces greenhouse gases by 20% versus petroleum-based PDO. We will look at this example in more detail later, because it's a nice example how quantitative life cycle assessment analysis can underscore the reasons for developing this process. It's not just the production of bio-PDO which is more beneficial. Also, the PTT polymer production process is more sustainable than the conventional approaches of polymer production. The structure of PTT saves energy as polymerization becomes easier. Also, the recycling of PTT products is easier due to the absence of heavy metals, which are required for PET production. And finally, PTT has excellent properties compared to PET. It's actually a better product. This is a true win-win situation. We can create a better polymer by using an economically and environmentally better production process. Finally, I would like to leave you with the message that the technology push is there to make propanediol, and we can also assess the environmental sustainability by a lot of quantitative measures. But in the end, what is important is if industry will start producing it, the economics, and if and how consumers choose and accept the product. So it's not just about the technology, it's also about societal value, functionality, and economics. The properties of the products, including recyclability and degradability, can be directed by a technology push, as is shown in the outer circle. But if you look at the whole context of a product, it's also important if people really want to use the product, if they find it important that the product has these properties and they can afford a price for these properties, and if it has social benefits on a rural and local level. This is important in order to develop a strategy for sustainable development. So there's a choice to be made here. Join us next unit for more technology for bio-based products.